A very good morning, everyone. I am Ms. Aditi Sinha, Assistant Professor of Department of Chemical Engineering of Haldia Institute of Technology. Today, I'm going to discuss about washing of coal. In the previous class, we have discussed about the washing of coal. That means before discussing the washing of coal, we have learned about what are the impurities present in coal, like fixed impurity, inherent impurity, and free impurity. And what is the probable effect of the impurity presence in coal, and how to remove impurities from the coal? Because as we know that calorific value is an important parameter that is determined in coal. So to increase the calorific value, reduce the clinkering tendency, increase the heating value, so we have to remove these impurities from the coal so that we can have the best quality of coal. So under these impurities, we have already gone through the objectives, the nature of the impurity present in coal, objective of the coal washing, and types of commercial coal washing method in the previous class. Still just a recap of it. That is gravity separation method. We were discussing about the wet process. We are discussing about the dry process. So today we will discuss about the wet process. Uh, so just this is a continuation of the previous class. So let's go to the wet process because we have already discussed about the dry process. So what is the wet process? This wet coal washing process are two types. One is chance process, another one is prompt process. What is chance process? This chance process is actually, it employs deep bath, and prompt process employs shallow bath. One is deep bath process, another one is shallow bath process. So let's study in detail about both the process. This chance process, since it's a wet process, so definitely there will be usage of water. So here the washing medium is a mixture of sand and water in such a proportion to have an intermediate specific gravity between clean coal and ash dirt. A deep bath of sand and water mixture is maintained in a trough where the clean coal floats and the dirt sinks and removed separately. This process is actually practiced in Jamatoba Washery Dhanbad. It is a dense medium water that employs a tank which is cylindrical above and prolongs downward into an inverted truncated pool. As the rock wool is fed into it from the top, the dirt sinks to the bottom while the clean coal, water and sand, this water and sand overflows onto the screens where water and fine sand drains out and clean coal is separated. So this chance process, where the washing medium, as I discussed, is a mixture of sand and water. And finally, after the washing process, the dirt sinks to the bottom while the clean coal, water and sand overflows onto the screen where the water and fine sand will drain out and the clean coal is separated. So basically, the whole process is dependent on the specific gravity, the concept of specific gravity. Depending on the specific gravity of the washing medium as well as the impurity as well as the coal, all the impurity with the medium, that is the sand and water, is separated. And this process is popular in the Dhanbad washery. Okay, so let's go to the next one. See, that is Trome process. This is also a wet process. To see this process, the diagram is given very clearly. We see the diagram exactly narrates about that where the coal is fed, the arrowhead given on the top shows the coal, that is the coal with all the impurity is fed from the top. This is a shallow bath of mild steel is provided with a push plate conveyor to discharge the clean coal and a scraper conveyor to remove separately the middling and the refuse. A low specific gravity and high gravity washing medium. What is the high gravity washing medium? That is water and sand, or you can use hematite. Basically, hematite is a form of iron, is fed separately. Both the media flow horizontally over the whole width and depth of washer. The two conveyors are run in such a way that the swell of the media is avoided. So the movement is done in such a way that the swell of the media can be avoided. The middling may be crushed and recycled to the bath. So let's come to the diagram in detail, what we have studied till now. So the diagram states that the coal is fed from the top. The low gravity medium is also fed here. This is actually a bath, and high gravity medium is fed here. There's a scraper conveyor, and this one is a push plate conveyor. This is basically a tramp shallow bath, okay, over which the scraper conveyor is present and push plate conveyor is present. In this bath, see, we have basically few sections. From one section, we separate out the reject. From another part, we separate out the high gravity medium. And from the other part, we separate out the middling and low gravity medium. And finally, we get the clean coal. So from all these zones, we get different category. One is the reject, next is the high gravity medium, next is the low gravity medium with some middling, and lastly, the clean coal. So this shallow bath and deep bath has some advantages. Like, what are the advantage of shallow bath over deep bath? It requires less fluid. It requires very low amount of fluid. That is the water we are taking here. And what is the advantage of dense medium process? This coal that we are using here, that containing this high proportion of near gravity material, can be efficiently washed. And what is the efficiency that is estimated here? It is almost 99%. So, due to this high efficiency, it is most widely used. So, this is the advantage of dense medium process. So, what is the disadvantage of dense medium process? It is inefficient in cleaning small coal size, that is less than 6 mm, 6 mm almost. And the quality of the solid material removed with clean product is greater. So the disadvantage of the dense medium is that inefficient in cleaning small coal size, where the particle size is less than 6 mm, and the quality of the solid material removed with clean product is greater. So the advantage of dense medium process is that the efficiency is almost 99%, so that is the reason it is widely used. And the disadvantage of the dense medium process is that inefficient in cleaning small coal size. Okay, so if the particle size is very less, it will become inefficient. Okay, and moreover, the best means the coal, this quality of the solid material removed with the clean coal will be greater. Now there is another washer, that is bomb jig and cyclone washer. See the bomb jig, it looks like a tank, that is, see here the air inlet is given and here is the water inlet is given. We have here a perforated plate with a supporting coal bed, this coal bed, and we have a stratified bed of coal and dirt. and we have a conveyor for fine dirt material. Now let's study this diagram in detail. This is a U-shaped box divided longitudinally by a vertical partition into washing and air compartment. The washing section is divided into two parts, each having a sieve. Sieve means mesh, having perforations. We have just seen. See here it has some perforations. Okay. Now this water pulsation is created in air compartment and related to the adjoining washing compartment. So water pulsation is created. And then the coal is fed at one end of the washing compartment. Larger piece of refuse collect at the bottom of the first section. The clean coal and finer dirt is carried forward over the vat to the second section. Here, the refuse sinks and the clean coal is carried by the flowing water over the discharge vat. The refuse is periodically removed through the valves from both the sections. Fine dirt falls through the sieve into the bottom of the washer and are removed by the conveyor. Now, this type of jig washer has some advantage. What are the advantage of this jig washer? It gives better separation efficiency for finer particle, that is from 25 to 200 size of coal than dense medium separator. It has high efficiency, that is 90% for coal with 10% near gravity material. High optimum capacity, that is from 200 to 400 ton per hour, and maximum capacity of 600 ton per hour. Now, what is the disadvantage of this jig washer? It cannot wash fines below 0.5 mm. So it is difficult to wash particles of less than 0.5 mm. So this jig washer has some advantage as well as some disadvantage. Now next go to the next slide, this cyclone washer. This next slide consists of this cyclone washer technique. It has a settling chamber in which gravitational settling force is replaced by centrifugal force. See the diagram. Here see the raw coal and dense medium is given from the bottom of the tank, and the clean coal is taken out from the top of the tank, and dirt is also taken from the bottom of the tank. It is a settling chamber, as I told you, and this cyclone washer utilizes the concept of gravitational settling. It utilizes the gravitational force and separates out the dirt from the clean coal. In the previous one type of washer, we have learned that it was based on specific gravity, and this cyclone washer is based on the gravity settling method. A pulp of deslimed raw coal and heavy medium magnetite is fed tangentially to the cyclone. The overflow from the cyclone contains the clean and the underflow contains the sink. These are depulped and the products are rinsed with water before final disposal. The recovered slurry of heavy medium is reused after suitable treatment. The capacity of the cyclone washer is normally 70 to 150 ton per hour. And the detail has been, schematic diagram has been shown in a figure. And this type of cyclone washer also has some advantage and disadvantage. What are the advantage of cyclone washer? Efficient for small size coal, high flexibility of operation with regard to percentage of near gravity material, coal size, feed rate and separation gravity. And the disadvantage of the cyclone washer is power consumption is more, maintenance cost is high. So that's all for the washing of coal from my class. Thank you everyone for listening.